Hey guys, just a video on intersection questions of lines. So just in case you want to try to figure this out before you come back, let's just look at a line in 2 space. So here's a scalar equation, 7x minus 3y plus 4 equals 0, 14x minus 6y plus 6 equals 0. Okay, so we just got a scalar equation of a line in 2 space, and we're trying to find out where these two lines intersect, if they do intersect. So remember, in 2 space we have options like we could have parallel lines that don't intersect, we could have coincident lines that are the exact same line, so they intersect an infinite number of times, or we could have intersecting lines that intersect once. So we want to figure out what's happening here. So first thing I do is I just compare the lines, and I think, okay, is there anything I can multiply the top line by that would make it equal the bottom line, say? So like, let's say I multiplied the whole top line by 2. My top line would become 14x minus 6y plus 8 equals 0. So that's what would happen if I multiplied everything by 2. And if I kept the bottom line the same, 14x minus 6y plus 6, I can tell my lines are almost the same. I got 14s and the minus 6s are the same. So I know from doing this proof in class that if you have the scalar equation of a plane, or of a line, sorry, the coefficients in front of x and y are the normal vector, so the vector that's perpendicular to the line. So if my two normal vectors are 14, negative 6 in both my lines, then essentially like it's saying my two lines are going to be either parallel or coincident. So I know that right off the bat. So if my coefficients in front of x and y are identical, then my lines are going to be either parallel or coincident. So if we just take our two lines and say we subtracted the coordinates from each other, so 14 minus 14 gives us no x's, negative 6 minus negative 6 gives us 0 y's, and 8 take away 6 is 2. I essentially just got like 2 equals 0, which doesn't make sense at all. So that's going to tell us that these lines are actually parallel, because we just proved, or we just found something that can't be true. So it just must mean that, you know, when we try to subtract these two lines from each other or sub one of them into another one, we're just showing that they don't overlap at all. So we actually have two parallel lines. Okay, so let's look at if we had vector equations of a line. So let's say we had the line 1, 5 plus s negative 6, 8, and we had another line that was 2, 1 plus t 9, negative 12. So we have a vector equation, two vector equations in 2 space again. So we have the same number of possibilities. So I think it's easiest if we well, first let's look at our direction vectors and see if they're going in the same direction. So if we look at our direction vectors, negative 6 and 8 and 9 and negative 12, the thing I noticed right off the bat is I could multiply, if I multiplied this vector by 2 over 3, it's going to equal this vector. So like 18 over 3 would be 6, 12 times 2, 24 divided by 3 would be 8, except my negatives and positives are different, aren't they? Yeah. So I'm thinking these lines are going to be parallel or coincident. because my direction vectors are pretty much scalar multiples of each other. Okay, so I already know it's going to be like that. So I could go 2 routes here. I could check and see if this point lies on this line by subbing 1, 5 in for x and y in a parametric equation. So let's make parametric equations. X equals 1 minus 6x and y equals 5 plus 8s, and my other equation would be x equals 2 plus 9t and y equals 1 minus 12t. So I've got this line and I've got this line. So I could try just taking this point 1, 5 and subbing it in here and seeing if my t's are the same. So I could try just doing that. So like 1 equals 2 plus 9t. So I'd get t equals negative 1 over 9. Or I could try subbing 5 in for that y. So then I would get t equals negative 1 over 3. So I see the t's aren't the same. So therefore that line does not lie on that line. So these must be parallel lines again. Another way to do it would be to equate the parametric equations. So if I want to solve for the intersection, I'm going to assume they have the same x and y point where they intersect. So I'm just going to sub them into each other. So I'd end up with 1 minus 6x equals 2 plus 9t. Has one equation. So I've got 2 unknowns, s and t. So I'm going to move them on one side. So I'm going to move my 2 over. So I have 1 minus 2 equals 9t plus 6s. So negative 1 equals 9t plus 6s. So that's one equation. I'm going to do the same thing with my y's. So 5 plus 8s equals 1 minus 12t. And then I'll just move my s's and t's around. So I end up with 4, if I subtract 1 from both sides, and negative 12t minus 8s. So now I've just gotten myself 2 equations and 2 unknowns. So I can solve that using substitution or elimination. So that's just that skill from grade 10 we were talking about. So if I want to use substitution or elimination, I think I'm going to go the elimination route since I got coefficients in front of my t's and my s's. So yeah, you just got to try to make the coefficients in front of the t's or the coefficients in front of the s's the exact same. So if I multiply this equation by 3 and this equation by 4, I can make both s's have a coefficient of 24, which means I have to multiply everything in this equation by 3 and everything in this equation by 4. You can multiply each term in an equation by anything you want to. So we got negative 4 equals 36t plus 24s, and my other equation ends up being 12 negative 36t minus 24s. So right away I can see my t's and s's are the same. So I know I'm going to have parallel or coincident lines, which I already did know that. Okay, so I'm going to add these equations together because I want to eliminate t and s. So negative 4 plus 12 would be 8. 36 plus negative 36 would be 0t. 24 plus negative 24 would be 0s. So I just proved that 0 equals 8, which doesn't make sense. So that's just telling me the lines are parallel. If the question would have shown 0 equals 0t plus 0s, then that actually does make sense. 0 equals 0. So in that case, the lines would have been coincident. Or if it would have actually given me an answer like 1 equals 2t and I could solve for t, then there would actually be an intersection point. Okay, so that's just a tiny bit of info about intersections in 2-space.